So in the last video, I talked about how when the calculated graph for the square roots of photon energy against atomic number or number of protons, the calculated graph was compared with the measured graph. The calculated graph is off by 1 unit. So that's something really strange when this result was first obtained in 1913 by Henry Moseley. In discussion with Niels Bohr, right, who made the hydrogen atom model. So they had to find some explanation about why it might be off by 1 unit, and hopefully there is some simple reason. I think at that time people know about how atoms combine to form molecules, and they know that this must suggest that there are only certain number of electrons allowed in each shell. So the idea that Moseley and Bohr came up with in order to explain this, it consists of a few points. Okay, the first point was that the lowest orbit, this n equals to 1 orbit, just call it orbit 1, it can only have 2 electrons only, at most. Now the next thing, so these are the ideas that people used at that time. Henry Moseley and Bohr used. So let me emphasize that these are the ideas. Okay, at that time they really were not sure, but today, after years of theory and experiment, we know that these should be correct today. So at that time there was just a lot of guessing, which turned out to be right in the end. So the first idea was that the orbit 1 only has 2 electrons. Okay, maybe. And the second idea, right, was that when in the setup to produce X-ray, we have a beam of very high energy electrons hitting the metal targets that produces the X-ray. Now the next point is about what actually happens when those electrons hit the atom. The second idea is that the incoming electrons, the high energy electrons, knock out one of the electrons from this innermost orbit. So one electron from the orbit 1 gets knocked off. So once it gets knocked off, right, then only one is left. So at first there are 2. Let's say at first there are 2 electrons. Okay. Now this one gets knocked off by a high energy beam of electrons that comes in and hit the metal. So that one get knocked off, but the moment this one get knocked off, there's only one left in the shell. So there's space for one more, alright, because it can take up to 2 electrons. There's space for one more. So then one from a higher orbit can fall downwards. Okay, so electron from orbit number 2 falls to orbit number 1, and when this electron falls to here, that's when the X-ray photon is emitted. Okay, so these were the ideas that were put forward by Moseley and Bohr at that time, and the idea leads to this this kind of a guess, if you like, or this conclusion, which is that when this electron first gets knocked off, and before this electron has fallen into the first orbit, when this electron first gets knocked off, there's only one electron left. So this one electron, would cancel off the attractive effect of one proton in the nucleus, the attractive effect on this electron in the second shell. Because this electron, it is the energy of this electron that we need to use in this calculation, right, for E2 and E1. So when it falls from there to there, okay, the electron only feels the attraction from Z-1 protons, because the proton attraction is cancelled by the electron that is still in the first orbit. So this electron, it feels attraction of Z-1 E, alright, of this charge only from the proton, because one of the Z protons is cancelled by the remaining electrons. I mean, the attraction is cancelled. So because of that, the Z here, alright, should really be just Z-1. And it is this -1 that explains why the calculated line was shifted by 1 unit to the left. So with these ideas now, Henry Moseley corrected this equation and replaced the Z by Z-1. And once he did that, this line is now changed to a line that goes here. Let me draw that. And it now fits the experimental, the measured values very well. Not exactly, but very nicely. So this, once again, right, with these simple ideas here, which sometimes were just made up, sometimes doesn't even look reasonable, right? But just with a few of these simple ideas, when it was possible to actually get very good agreements with the experimental result, that's when people started thinking that about whether these ideas have some truth in it. And after years of research, right, it was found that it is indeed true that the first orbit has only 2 electrons, and that all these processes are, at least qualitatively, the correct picture of what happens in when we get the characteristic X-ray spectrum.